today I'm going to be predicting recidivism using Bayesian networks, and my advisor was Dr. Duncan. So just an overview of what we're going to talk about today. Part one, I'm going to introduce the issue of recidivism in the United States. I'm going to introduce my research topic / the question that I tried to answer in my project, and then also I'm going to explain what Bayesian networks are, and I'm going to show you guys an example and list a few fundamental rules that you use in statistics in general, but also that I used in my project, and then my findings and applications, how they can be applied. So first of all, what is recidivism? Recidivism is the act of a recently released convicted offender to reoffend, thus being reincarcerated. So just to give you an idea, before I start with the rest of the bullets, whenever I say violent offender, I mean anything that has to do with assault, homicide, murder, anything like that. And then nonviolent goes, a nonviolent offender would be anyone charged with drug charges, theft, burglary, anything like that. So just to give you an idea of the United States rates in 2019, this second bullet is only United States, 64% of violent offenders reoffended within 8 years of being released. And 40% of nonviolent offenders reoffended within 8 years of being released. So those numbers are pretty high. Right now in 2021, as of right now, obviously we're not done with the year, United States is listed as the third highest rate of recidivism, and we are right behind India and China. To give you an idea of how that compares to countries around the world, Norway's recidivism rate is only at 20%. They say this is because they focus on repairing the harm caused by crime instead of focusing on just punishment. So a few violence risk assessment tools that are used. These are some common ones. They're not the only ones, but they're called the VRAG, HCR, and SAFRI. They all use different point systems and questions about the offender, and they all consider different variables as well. So some of them consider historical risk factors. These can be how did the offender grow up, who raised the offender, how they adjusted to school. Clinical risk factors, these can be how the offender's mental health is right now, do they have any diagnoses that anyone knows about, and then social and contextual factors. This is any current factors. This can be how violent was their offense that they're being tried for, anything currently happening in their life right now. And so these violence risk assessment tools are used in trial and upon release. So in trial, whenever trying to convince a jury, if we don't put this person away now, what's the likelihood that they're going to continue to be a threat to society? And then also upon release, when someone is thinking about being released, they want to visit this because they want to know, if we let this person out now, what is the likelihood that we'll see them in the next 3, 6, 9 years? So now we want to talk about why this matters. I wanted to look at the specific variables that predicted recidivism better than others, and from my findings, I was hoping to look at starting prevention programs. We can use this information to start prevention programs like rehabilitation programs and also programs while someone is incarcerated. We also want to know what part of prison is working and what part isn't working. Obviously, there's a difference between our recidivism rate and what we focus on while an inmate is in prison versus Norway's recidivism rate and what they focus on while their inmates are in prison. And then the question that I wanted to answer in my project, who is most likely to fall into the recidivism trap and why? So I'm going to look at specific variables and see which ones are better predictors than others. So now I'm going to introduce Bayesian networks. A Bayesian network is a probabilistic network that represents a set of variables and their conditional dependencies. It captures both conditionally independent and dependent relationships between random variables to infer and estimate the probabilities for causal or subsequent events. So that's a really long definition, so let's just go ahead and put it to use and construct a Bayesian network. So our example, SPAMMY is a program. It's trained on a set of 1,400 messages where 1,000 of them are spam. The word opportunity appears in 175 messages and 20 messages that are not spam, and the word free appears in 300 spam messages and 22 messages that are not spam. So we're going to go ahead and start constructing our Bayesian network. These blue arrows right here indicate direct influence. They're called nodes. So we know in our example, spam directly influences whether the message contains the word opportunity or free. So that's why there are two arrows going from spam to those two variables. Notice that there's no node or arrow between opportunity and free because we're not looking at that relationship. Having the word free in a message does not affect whether the word opportunity is in that same message. So to finish up our Bayesian network, what we're going to do is add in the conditional probability tables. These are filled in using information from the problem. So just to give you an idea, the information we were given was that there were 1,000 spam messages out of all the 1,400 messages that Spammy was trained on. That's how we get that probability. Everything else, the 400 out of 1,400 is how we get this probability. Next, we read this as the probability of F given either spam or not spam. And so we were given 300 messages that were spam contained the word free, and 175 messages that were spam contained the word opportunity. So we fill those in using information from the problem or data set, and from here virtually any probability can be found. So these are just some important rules to remember. These are just rules that you use in statistics, but also the main rules that I used during my project. So there's the chain rule. So let's say you're given three events, A, B, and C. It simplifies out to this long equation here. And notice that A and B and C are all interchangeable. The commas mean and here. But A, B, and C are all interchangeable. So in our example, we know that the probability of C is the probability of a message being spam or not. That's what we were given. We know that. Let's say, so that's why it's in the last place right here, because we know we're going to have to multiply by it by itself later on. Let's say we were given the probability of a message having the word free in it. We could manipulate these variables and change them around because they are interchangeable to get our simplified expression and multiply by that later on. Next is the conditional probability rule. That's just saying the probability of an event A given event B simplifies to the probability of A and B over the probability of B. And then the principle of marginality. So let's say we have two variables, A and B. We want to find the probability of A, but we're not given that. We know that there can be two possibilities for A. There's A and B, or A and not B. Those are the only two options. So that's how we get that. If we add those two up, we're going to find the full probability for A. So these are just some rules that I used while I was doing my computations. Now we're going to look at the data set that I used. I used a data set from the University of Michigan's website. It was called the National Longitudinal Survey of Youth, and it included ages 14 to 25. It was around 9,000 participants. But for my project and for this purpose, we only wanted to look at legal adults, so we narrowed down the data set to only include ages 18 to 25. So now we can start adding in our own variables or testing the variables that we're given. So there were tons of different variables. This is where you can kind of pick and choose what you think would be a better predictor of recidivism or not. I wanted to look at cohabitation with a spouse or partner and enrollment in an educational program. So these were, again, included in the data set, but I narrowed down on these two because we figured that if someone was living with a spouse or a partner, they're more than likely in a more serious relationship or trying to support that spouse or partner. And then enrollment in an educational program, that person is probably trying to plan for the future. They're putting time and effort into a program. They're not planning on returning to prison. So now we can construct our network for my problem. Thankfully, our network is set up the exact same way as our example problem. We just substitute our old variables with the new variables that we want. So we have reincarceration. Notice I said reincarceration. We don't care if someone has been, we care. We don't want to look at if someone has been incarcerated only once. We want to look at who is returning because we're looking at reincarceration. That's the rate of recidivism. So out of the roughly 9,000 participants, 299 of them had been reincarcerated, so incarceration more than once, and then the rest had not. So that's how we get these values up here. And then cohabitation, we know that an offender, someone being reincarcerated has a direct influence on if they were living with someone or if they were enrolled in an educational program. So out of the 299, only 155 of them had been cohabitating with a spouse or a partner, and the same 299, 216 of them were enrolled in an educational program. And so here, this is just saying that we use the variables R for reincarceration, C for cohabitation, and E, enrollment in an educational program. So our findings. We found that if all of these variables were present, cohabitation with a spouse or partner and enrollment in an educational program, the individual was less likely to reoffend, thus finally escaping the recidivism trap. So this is just to give you specific numbers from our data set. This is only from our data set. It showed that the probability of reincarceration, given they had lived with a spouse or partner for at least 1 year from 18 to 25, and they had been enrolled in an educational program for at least 1 year from 18 to 25, was only around 2.45%. So that's pretty low. I also wanted to break it down and see which one out of the two was a better predictor. So the probability of reincarceration given someone was only cohabitating with a partner or a spouse was around 3.16% versus the probability of someone being reincarcerated given they were enrolled in an educational program was around 2.58%. So we can see here that cohabitation with a spouse or a partner has or the two variables have different weights on and are different predictors of recidivism. So how does this help? We can start looking at programs during incarceration and after incarceration. So during incarceration, like I mentioned earlier, this can be educational degrees or vocational degrees, helping inmates achieve those skills, work towards those skills that they need for the workforce whenever they are released. And rehabilitation programs once they're released. So we know that if someone has a job, they're probably putting more time towards the job than engaging in criminal activities. And if someone is in housing as well, we need to start providing housing for inmates once they're released, especially if they've been in there for a long time. We don't really think about where they have to go after this. They haven't been working towards their future because they've been in prison this entire time. So these are just a few programs that I think would help lower the rate of recidivism in the United States. And for future work, I wanted to look at different data sets or the same data set to see third and fourth time reoffenders, or just like a specifically high number, to see what they all have in common, because it'll probably be a small number, what they have in common, what predictors are, or what variables are better predictors given, like compared to our data set that we have. And also these are some different variables that I was looking at. These were included in the data set that I had a hold of. And so I was looking at biological mother's age. I was thinking this because the younger a mother is, the more likely she is to live in poverty, and we know that poverty-stricken neighborhoods are kind of infested with crime more so than others. Age of first arrest. If an offender has a run-in with the law at a very young age, that's probably going to affect them for a while. It's going to introduce them to that lifestyle earlier on. Household income, this is the same thing, poverty ratio. And then weeks worked in a year. If someone is working full-time, they probably do not have the time to engage in criminal behavior. And then lastly, I also wanted to look at the actual data, the actual number for the United States, their rate of recidivism, and substitute that in my calculations. And these are my sources.
Feel like you know what I'm going to ask now.
Mm-hmm.
Do you have any questions for Briana? Mrs. McCoy and then in the back.
Okay.
So, one is, would you consider also looking at, as opposed to education programs, work programs, to see how those relate to recidivism. Specifically, I asked because there are puppy raising programs for the organization that I raise for, and there is marked decrease in whatever that word is, for the people that partake in that program and assist with the dogs. And as a double bonus, the dogs that are raised in those programs happen to be better dogs when they come out of the program because of the amount of attention that they're able to get. So I would just mention that as a place. And then the other place, when you're talking about education, did you look at all at the education level of the person related to first incarceration, or I suggest that as a place, because there's also that direct link
Yes.
for how our education program is not being successful.
Yes, so I did want to look at that as well. Unfortunately, this data set didn't get that specific.
Mm-hmm.
It did have the ages though that they were in an education program. So some of them were up to like 24, age 24. So I'm assuming it'll give us an idea of what level education they're at. But obviously, again, we do want to look for more specific data sets, and that's something that I would look into in the future.
Do you think that in the future those type of statistics will potentially be used in deciding like parole for some inmates?
It definitely can be. So obviously, if they're going to want to have more strict restrictions, I guess, on an inmate if they know that their likelihood is higher to reoffend in the future.